I guess I should take a look at this one. The solution is corrosive, reacts bitter. Bitter is a base. Bitter is a base. So that is A. Okay. All right. This is the second version of the quiz. The first version I already went over in class. Second block is going to get a third version, but all the versions are based on the same concepts. And that's when you're in your lab, so each question I'm going to go over it, over each question, talk about the concepts and how you choose the right answer. What's key is I'm also going to tell you where to go look for the information, especially if you got a wrong answer on version 2 or version 1 or for block 2 after they take version 3. If you get a wrong answer, you have to figure out exactly where you got, why you got that wrong answer, why was the right answer right. So here you see it says in your lab, you take a white solid and mix it with another white solid, and there was no perceptible change. The thing I'm looking for in this question is, do you understand that no matter what, you really can't tell if a chemical reaction has occurred, a chemical change or physical change has occurred until you look at the result, at the product, and compare it to the reagents, the reactants. So after the reactants, when you take A and you add it to B, and you get some kind of C, right? Once you compare this C, once you look at C and you say, is this the same as either A or B? Okay, this is the only way you're going to be able to tell if it's essentially changed. And there you're going to be looking for physical characteristics, so you can't see them, but there might be some chemical properties that might have changed. For instance, if it changes litmus paper to a different color, maybe it doesn't change litmus paper at all, or so it's not an acid or a base any longer, or maybe it reacts with metals where it didn't react with metals before. So you're looking for some kind of change that's going to allow you to do that. As you move forward, you look at number 2, and it's looking at a phase change diagram. You go from A, which is the solid. This is a solid here. C is a liquid, and E is a gas. That's right out of your phase change diagram activity. That's the stuff we did in class. I explained it. But when you're looking at changing in temperature over time, you're looking at a change between a solid, liquid, and gas. Remember, a solid has a definite shape, so you have these, all the molecules or atoms or particles, if you will, all of them are compacted together. They have a specific distance from each other. They're attracting each other in a specific way. We'll talk about intramolecular forces in the future, but just know that this is a solid. That's where this A is, all right? It's at a lower temperature than it would be when it's a liquid, and when you're looking at a liquid, it does not have a definite shape. It has, however, a definite volume, okay? And the particles are further apart. Then that's a liquid. So then you have a gas. Now gas fills up the container. A gas has no definite volume or definite shape. So this is the gas. This is the gas. There's the liquid and the solid. So it makes sense when you're heating up, if you remember that as temperature goes up, as you go up in temperature, you're increasing the average kinetic energy. So it makes sense that as I increase the flame over time, the substance is going to get hotter and hotter. That's why this line rises. Now the question is, why does this line, when this line gets to B, it doesn't go up anymore. So it was a solid, and as the thing gets heated up, it starts to turn into a liquid, but the temperature doesn't increase any further. So to 0 degrees in the case of the experiment we did in class, the ice, to 0 degrees, it doesn't go up to it doesn't go past 0 until the whole thing turns liquid. And the reason is that the energy that goes into the system from the heat is going to separate the molecules, because until these molecules get separated, they can only vibrate to a certain point. In this case, it's at 0 degrees Celsius. Until you separate the molecules, they cannot vibrate any further. But once they've changed state completely, they've turned into a liquid, then you'll notice that they can increase in temperature again, no problem. Until they reach this point. Now, what's this point? That's that transition from liquid to gas. that we call vaporization or boiling, right? So here it's melting, here it's boiling, and then again, these molecules in the liquid form can only vibrate in two directions, only as far as they can move, and they can't move any further because they have that definite volume. So they have to transition to a gas before they can get any hotter, or in other words, they can before they can vibrate even further. Once they're all a gas, they can move into every corner. They can hit every corner of this container. They can fill up the whole container. So here, once they hit a gas, the temperature just keeps increasing until you reach the next phase of matter. Okay, I hope that explains this temperature change map. You will see this temperature change graph again on the exam. You'll see all these questions again on exams. They'll be in different forms. They'll be in different contexts. So you need to understand this. That's why I'm doing this video. Okay, so now, as we go on to 3, you'll notice that it's asking you what's happening at B and D, and I've already answered that. But you'll notice that what they ask you in this, what I ask you in this question is, in the first version, I asked you what was happening when it was increasing, right? When it was increasing, when the temperature was increasing, when it was warming up. Now I'm asking you in this question, what's happening when the stuff is cooling down? So when it's cooling down, they're not breaking up the molecules. They're not doing this. They're not making up the bonds. You're not getting them to separate. You're getting them to come back together. So the answer is B. We're up here for letter D. It was going from liquid to gas. So that's answer B. And number 4, the solution is corrosive and reacts with that was a mistake in the test. This should not have. This part should not have been here. You can scratch that out. So a solution is corrosive and tastes bitter. Right? That was my mistake. I apologize for that. What might it be? Well, if it tastes bitter, it's a base. Where are you going to find all the qualities of acid base? They're in your PowerPoint. It's in your email. There's slides, specific slides. Actually, there's 2 of them that talk about the qualities of acids and the qualities of base. All right? You need to go through those slides. You need to make index cards. A lot of people got the properties of acids and bases, and they're telling me, the people that took the test, they didn't know what the qualities of an acid or base was. I don't know why. I went over them in class, and I told you, and I not only did I go over them in class, but I gave you a PowerPoint with that, with those. So the next question then says, a solution turns red litmus paper blue. So okay, so red litmus paper turns blue when you have a base. All right, so red litmus paper turning blue is when you have a base. Again, you can have red going to blue, all right, or you can have blue litmus paper turn red. That change is a chemical change that happens specifically because you have in the case of red to blue, you have a base. All right, in the case of blue to red, you have an acid. You need to get that straight. It's in your PowerPoint. Make sure that you get it correct on the next time you see it. We'll be using that information, but I won't be asking you the same questions. You have to understand the content. And student, and remember that the pH difference, pH is a difference is by an exponential, so it's 10 to the x, and the x here is your pH number, right? So when you're dealing with a difference of 10, in the case, I'm sorry, of 2, this is also an error in the, I had people correct when they took it. That's not 10, that's 2, right? So a difference of 2, right, is stated here. What does a difference of 2 really mean? What it means is that you're dealing with something that has a 10 to the second difference. So that's 100 difference between the two of them. So if you have a pH of 7 and the other one has a pH of 9, the difference between them is not 2, it's 100, right? Because each time you take it up a notch, you're increasing it by an order of magnitude. Okay, so you're looking now at 100 kilogram block. Often I like to draw things out when I'm given a question like this. So you have a 100 kilogram block of salt. So it's a big 100 kilograms. Kilograms is mass. Someone asked me that. I wasn't sure why. Then you have a little bit, 1 milliliter is, if you remember the graduated cylinder, it's a tiny bit of liquid. So you're pouring that liquid into the block. All right, so if I do that, which is the solute? Well, I hope you know that the one that's in larger amount is a solvent. So this is a larger amount. It's making this. It's making the water disappear. So this water is disappearing into the solvent. The solvent in this case is a solid. So what is the solute? The solute is the water, the liquid. It's strange, but that's what you got to try to remember, is that the definition has to be applied, not what you're used to dealing with. So in figure 2 shows a solution that is, if it shows you, if you take a look at it carefully, and in the particular photocopy I had, this wasn't very clear, but I did put no solute reaches the bottom. You'll notice that the solute is not reaching the bottom. There's the middle, and that's the bottom, because it's being dissolved. So we're calling that an unsaturated solution because it's still accepting more solute. Remember that the more solute it accepts, the better. Now, if the results dissolving mass at this particular example is happening at 55 degrees, what would most likely happen if you cooled it off to 20 degrees? So you bring it down. Well, first of all, for sure, you would have less. If you're cooling it off, you're going to have less of the solute being dissolved. That's correct. Obviously, if you have less, well, then this can't possibly be more, right? And then the next question is, there'd be less space for the salt to hold the solute. Well, that's true. So that makes D the answer. That makes D the answer because both A and C are correct. And that goes back to the idea that when you're dissolving things, you're talking about, if you're dissolving the red dots in the blue dots, then what that means is that the the molecules that are being dissolved in the spaces between the molecules that make up the solvent. Okay? All right, we've talked about that before, and that's going to be very key in biology, so you really got to get that in your head. Now, number 10, you'll see that the figure 3, which is a solute, figure 3 obviously shows the soda bottle. It shows you suds. It has little bubbles. The bubbles inside the bubbles, of course, are gases. I hope you understand that by now. Letter B should be pointing to the liquid. It was in the photocopy. For some reason, it doesn't in the translation here into the PowerPoint. But the liquid is holding the gases, as we discussed in class. The bubbles are being released from the gas. So at that point, you know the solute is the gas, which is A. All right, and that takes us through the quiz. Please make sure you review all your answers for both version 1 or version 2, and you understand exactly what's going on with each of these concepts, because you're going to see these questions again. All right, good luck, and goodbye.